This podcast is here to help you out to get ready for the Chapter 6 quiz. It's coming up this Friday, January 13th. It's over sections 6.1, 6.2, and 6.3. The first thing I want to go over is the vocab terms. I recommend that you just go through the definitions in your glossary. You've gone through and written them all down as we've gone through them in class, so I just would recommend you go through those. Do notice, though, that not all the words you wrote down are on the list on the study guide. Make sure you study the ones that are on the list a little bit more. Still good to know the other concepts, though, because they will come in handy later on. Now, going through the concepts, the first one I want to talk about are the relative amounts of the gases in our atmosphere. As we talked about in class, it's about 78% nitrogen, 21% oxygen, and 1% other gases, composed of all the other things that we see in the atmosphere. If you take a look at this graph here, you can see on the pie chart we have 78% nitrogen, 21% oxygen, and then there's just that little bit of argon right here. You can see where my mouse is pointing at, and that takes up the 1%, and everything else, including the carbon dioxide, water vapor, all the other stuff falls in that 0.1% range. The next concept that we talked about was that how density and how it relates to pressure and altitude. Now, this one we had a little bit of a struggle with as we've gone through it, but I think we're starting to get a good handle of it. Density goes up as altitude goes down. Now, this is kind of the opposite of what we saw in class, because we kind of flipped everything. But basically, the density goes up. That means it becomes more dense. It sinks, and this fits along with what we've seen when, if you try looking at something sinking in a bowl of water or something like that. It follows the same principles. We've also seen that density goes down, altitude goes up. When we heated up the balloon, we actually increased the volume, which, as you should remember, and I'll go ahead and write this up here. You should remember density is equal to mass divided by volume. And so that means that when the mass stayed the same and the volume was increasing, so if the volume increased, that means this number became bigger. The denominator becomes bigger, that means this number must get smaller. Now, the next thing to look at is pressure goes down, density can go down. Now, it's not a guarantee that density is going to go down, but usually if we decrease the pressure on something, that means that it's probably going to expand a little bit too, which would mean that density would go down. And then finally, when pressure goes down, altitude for sure usually goes up. And what that means is that, like, as you climb higher in the air, we usually see the pressure going down. The altitude means the altitude will go up. At the same time, it usually means that the density is also going to probably go down. This all makes sense when we think about the idea of pressure and think about how if we look at a quarter, there's actually 11 pounds of pressure pushing down on a quarter. And so just that quarter, holding a quarter in your hand, there's actually a tremendous amount of air pushing down on it from that column that extends into outer space. The next concept is how pressure is measured. Now, we just use a pretty simple device called a barometer to do that. And what happens is that air presses on the surface of the barometer. Either it's that coil inside an aneroid barometer, or it's the mercury inside of a mercury barometer, and causes either the liquid, mercury in one case, to go up or down the column, or the needle to move back and forth like in an aneroid barometer. It's important to make sure, though, that we understand that basically when it presses on it, it increases the amount of movement and it makes it go higher, showing that it's at a higher pressure. The characteristics of each layer of the atmosphere is the next concept, and there are four main layers: the troposphere, stratosphere, mesosphere, and thermosphere. If you take a look at the troposphere, weather occurs in the troposphere. It's changing, very turbulent. This is where we live at as well, and we typically see that we have all the different weather conditions, and it goes up about 12 kilometers or so. The stratosphere is actually where the ozone layer is at, and that helps protect us from the UV rays coming from the sun. It helps to keep us nice and safe. The mesosphere also helps us out. It actually protects us from meteoroids and other objects in space. If they are coming towards Earth, they will actually burn up in the mesosphere to help protect us. And then finally, there is the thermosphere. That is the outermost of the main layers of the atmosphere. It's also important to know the order of the four main layers of the atmosphere. And the order that we usually think of is from the surface of the Earth to outer space. And again, that's just troposphere, stratosphere, mesosphere, and thermosphere. My recommendation to remember this is just go through it a few times and you'll get it. And then the last one is how the density of gases in the upper atmosphere affect humans. I'm going to draw a diagram again. We looked at this diagram in class a couple days ago. And what we saw with this diagram is that we actually drew two boxes here. Alright, here's one and here's two. Now, in these boxes, we actually said this one was at the surface. And let's say this one's in an airplane. Now, I'm looking at the air outside the airplane, obviously, because inside an airplane we know they keep it nice and safe for us, but we're looking at the air outside the airplane. Now, if we were to look at the molecules of air, we know that it's going to be more dense closer to the ground. So that means we expect to see more molecules, because I'm saying these are the same size boxes, so we see more molecules there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 molecules in this one, and I'm going to put 5 in this one. So it's about half as dense as the other one, or this is half as dense as the surface. Now, when we look at this then, that means there's less molecules there. So of course there's less pressure, we have less molecules pushing on us, but then we also have to remember that as humans we breathe oxygen. And in our atmosphere we said there's 21% oxygen in there and 78% nitrogen. Now if I just break this down a little bit easier for the math's sake, I can actually say that it's roughly 1 in 5 molecules is O2. So that means then if I look at this molecule here, I can say this one and let's go with this one are oxygen. Whereas over here I have just the one molecule of oxygen. Now, in all reality, there's the same percentage of oxygen in both situations. But if I was going to be a human trying to get oxygen out of the air, it would definitely be a lot easier to breathe down here. There is more of it. It's easier to find oxygen. Now, up here in the airplane, though, we actually need to take some precautions to help keep ourselves safe. And this is the same thing you have to do if you climb Mount Everest or something similar. You need to make sure that you carry oxygen with you or add additional oxygen. So we can add O2 by using like an O2 tank or something similar to that. Alright, so once again, just to remind you, this quiz is over Chapter 6, Section 6.1, 6.2, and 6.3. It's this Friday, January 13th. If you have any questions, you can jump onto Moodle and ask questions, or you can ask me again during class. Good luck!